Welcome to geometry class. Let's talk about using corresponding parts of congruent triangles. This really is not any new rule, it's just an application of some of the rules we've already learned. But it's important to be able to reason your way around the triangles and draw appropriate conclusions. First thing we need to talk about is this idea of using overlapping triangles. Sometimes triangles have sides or angles that overlap, that is, sides or angles that they share in common. And we can use that to try and solve problems. One of the things that's helpful to do sometimes, and particularly when you're beginning, is to separate the triangles, pull them apart so you can see two distinct triangles, and then begin to reason from there. Always remember that a common side or a common angle is congruent by the reflexive property. Let's take a look at an example. Here we have two triangles, triangle ACB and triangle DBC, and you can see down here that they share a side, that is CB is common to the two triangles. So one of the things we might do to get started in this problem is go ahead and separate the triangles. And this is just a sketch. It doesn't have to be perfect. So I'll go ahead and draw those separated. There you can see the two triangles if we separate them. This is point A, B, C. And on the right side we have point D, B, and C. And the whole point of what we're talking about here is to first recognize that segment BC on the left is congruent to segment BC on the right by the reflexive property. It's the same segment, so it must have exactly the same size and shape. From there, sometimes we'll be able to solve a geometric problem. So for example, suppose we had the following additional information. Suppose we knew that angle BCD was congruent to angle CBA. And we also knew that angle D was congruent to angle A, like that. And we are asking the question, are there any congruent triangles in the problem? Well, when you move the information down below, again, you see that angle D is congruent to angle A. And again, angle ABC is congruent to angle DCB. And so you can see by angle, side, angle, side, we have congruence. Okay? So to be a little more specific, we could then say that triangle DCB is congruent to triangle ABC. So that's how we use overlapping parts of triangles in a particular diagram to get a little more information that will help us come to a solution or an answer. The thing we need to talk about is using two pairs of congruent triangles. Sometimes you're dealing with a situation in which there are multiple congruent triangles, and you need to reason into one set first. Then by CPCTC, you'll draw an additional conclusion, and then you'll be in a position to reason from there. Take a look at this diagram. Suppose we had the following information. Okay, in this diagram, you'll see we have two sets of triangles. You could actually make an argument that there are more. We have triangle ABE and triangle CBE on top, and then triangle ADE and triangle CDE on the bottom. I'm trying to find out the value of X. And the problem is we don't know whether segment AB is congruent to segment BC. Just because it looks like it might be the same length is never enough. We need a rule to be certain about that. And when we look at it, when we look at these two top triangles up here, there's just really not enough information there. I do have a side here. I've got this side BE congruent to itself by the reflexive property. And I also have angle ABE congruent to CBE up here. That's a given. But all that gives me is angle side, and angle side is not enough to prove congruence. So that is not going to carry the day. We need more information about those two triangles in order to prove that those sides are congruent and then find X. So let's see what else we can find in the diagram. When we look at the lower two triangles, triangle ADE and triangle CDE, we have more information down there. We're given congruence of these sides, that is side AD and side DC, so that's side. We have congruence of these angles here, these adjacent angles, angle ADE and CDE, so that's angle. And then we also have this side in here, which is segment DE, by the reflexive property, is congruent to itself, so we have side, angle, side down there, which means that triangle ADE is congruent to triangle CDE. And that's where we start. Now that we know those two triangles are congruent, we can use CPCTC to bridge the gap. CPCTC very often works, as I suggested, as a bridge between two different parts of a problem. So in this case, we're going to use the fact that triangles ADE and CDE are congruent to begin to draw other conclusions about the triangles up above. First thing that I'm interested in is realizing that this angle here, angle DEC, is congruent to angle DEA. And again, that's by CPCTC. Corresponding parts of congruent triangles are congruent. The next thing I notice is that BED here, angle BED is a straight angle. Because angle BED is a straight angle, that is, there's a line there, and angle BEC is a supplement to CED, whereas angle BEA is a supplement to AED, we know that the supplement here to these congruent angles down below must be the same. That is to say, supplements to congruent angles must also be congruent. Okay, so now when we focus up here at the top, we find that we now have an angle side by the reflexive property, angle side angle. So now we can be certain that triangle ABE is congruent to triangle CBE. The last part of the problem, of course, is to still find x. And again, by CPCTC, if those two triangles are congruent, then the corresponding sides AB and BC, or AB and CB, must also be congruent. And by the definition of congruence, their measures must be equal. Therefore, 4x equals 12 plus x. And we can solve that pretty easily. 3x equals 12, therefore x equals 4. So that's how we use CPCTC, again, to bridge different parts of a single problem, to work our way around, and hopefully come to an accurate conclusion when we're done. I recommend you find some problems to practice that on. Look for problems that involve CPCTC. You could probably Google CPCTC problems. You'll probably get a pretty good list of problems that involve that same sort of reasoning. And as always, if you have any questions, go ahead and leave a comment or shoot me an email.